Hello everyone, my name is Khalid Hussein and my partner is Nicholas Elaser. Today I will start by giving us a brief introduction about our final project and explain what we worked on. Firstly, we must understand what is image in painting. Image in painting is a tool for artists and designers who need a simple way to quickly modify images. This is done by creating a mask on top of an image and having the model insert the desired object into the masked area. Image in painting is important because it has the potential to reduce time required to manually edit the images. Currently, there are multiple ways of doing this. One of the more popular methods of image in painting is to only use the information from the unmasked regions of the image. Another approach is to use a secondary mode of features such as text to describe the image. In this slide, we can see that we are combining the sketch of the image with the masked image and the text and running it through our Inpainting model to finally get the result. One of the current methods uses the GCNet model, which combines the sketches with the masked image and runs it through the model to get the final result. The advantages of this model is that we have more control over the structure and the pose of our image. However, we are not able to control the details such as the color and the texture. Another method is to use text to describe the image. For example, the TDNet model. Over here, we can see that the text describes the image, which is red bird with black throat and cheek patch. And here we can see the result. And for this model, the advantages are the opposite and the cons are also the opposite. So we have more control over the attributes and less control over the structure and the pose. So from observing the pros and cons, we hypothesized that by combining the inputs, it would be complementary. So now I will pass it off to my partner, Nicholas, who will go over in more details about our proposed solution.
Thank you, Khalid. So our proposed solution is essentially an extension of this TDA net network that we saw a moment ago. So the TDA network only works with text inputs, and it has at a high level these three components. The first being a text encoder, which learns how to extract information from the caption. The second being the image encoder, which learns how to extract information from the masked image. And then finally, it learns how to combine these and then reconstruct the image. Our modification is only to the image encoder. And what we do is we expand out the inputs to allow for this sketch to be added. And then we also modify the image encoder itself to make the structure more resemble that of the GCNet, which was the model that used only these sketch inputs. To evaluate our proposed solution against both the TDANet and GCNet, we evaluate the reconstruction quality on a set of known images for each model using these four common metrics. And so we can see that the GCNet performs the best, and then our modification to the TDANet performs significantly worse. And so what this means is that the GCNet has the best reconstructed images, the most likely to be acceptable, and then our proposed model has images that are less likely to be acceptable. And so here we can see some results of the GCNet. So we can see how we mask out a certain part of the image and then sketch in a different pose, and we're able to reconstruct a different pose. However, we lose the color in the beak because we were unable to keep that information. And so then this is a further example. We have this yellow bird, and then when we reconstruct the yellow bird, we see we maintain the same sort of shape of bird. However, we sacrifice these sort of defining characteristics, and we just have this more generic looking bird. Comparing that to the TDA net, we can see that we're able to change the color of this bird rather easily. However, on this next slide, we can see that while we're able to generate a semantically correct bird, the fact that we have no structure in this information means we actually have this merging of two birds, which is undesirable. We can see our results. So the first test we did was modifying using these text captions. So we can see we still retain this ability to modify the sort of details of the image using the text captions. It's also noticeable these sort of artifacts we're getting, which likely contributes to the poorer loss we observe. And then on this final slide, we can see that our model actually failed to gain any ability to use these sketch images to modify the pose. We have the same images seen before, trying to redraw the head in a different pose, and we can see the model totally fails in this instance. That is our final project. Thank you very much for coming and listening to our presentation.